Today I would like to talk to you about the Penn State Inservice Workshops in Astronomy. These are annual week-long summer workshops that we teach at Penn State that help high school teachers educate their thousands of students better about topics such as black holes, cosmology, stars, and the scientific method. And these workshops have a 25 plus year history of success here at Penn State University. Today I'd like to tell you about the audience for these workshops. Here pictured is the 2023 workshop attendees. I'll tell you about how we teach the workshops, about how we assess the workshops and follow up on them, and then I'll end with some broader lessons learned about from teaching these workshops. Here are the two most recent workshops that we've taught on the lives and deaths of stars and black holes. These are advertising flyers for the workshops. You can email me if you have interest in being added to the distribution list for the workshops. In terms of the audience served, well, ultimately, we are aiming to improve student astronomy education in Pennsylvania, which is a large U.S. state, has about 13 million people, and Pennsylvania's neighboring states. Our overall approach is to teach the teachers, which is a high leverage approach, because each one of these teachers will go on to teach many hundreds or thousands of students in the coming years. Annually, about 12 to 18 teachers attend our workshops, and we make special effort to recruit teachers from underserved rural and urban school districts. They are supported with NSF scholarships, which cover travel, lodging, meals, and so on. And then the teachers also receive continuing education credit for the workshops. That requires workshop accreditation, but it's very valuable and helpful for the attending teachers. In terms of the instructors, well, in recent years, the main workshop instructors have been myself. I'm a professor at Penn State. Chris Palma, pictured here, who is a Penn State teaching professor and an author of astronomy education research articles. Glenn Goldsboro, pictured here, who is a master teacher of physics and astronomy at Pennsbury High School. He brings a critical perspective in making this the material we teach actually useful to the high school teachers. And the way things break down is generally I lead content lectures, and then Palma and Goldsboro lead hands-on activities and discussions on pedagogy and curriculum, and also lead nighttime observing and so on. In addition to the main instructors, well, the Penn State Department of Astronomy and Astrophysics, one of the largest USA astronomy departments, provides additional guest lecturers. And here pictured are three guest lecturers from our 2024 workshop on black holes. And these included postdoctoral scholars and professors who brought in their expertise and covered a number of other very interesting topics of importance to the workshops. In terms of standards, well, the workshop content, we put a lot of effort into aligning this with the next generation science standards and with the Pennsylvania so-called STEELS standards, which stands for the Science, Technology, and Engineering and Environmental Literacy and Sustainability standards. And in addition to sort of making sure we check the boxes in terms of content coverage with these standards, we also put in significant effort to illustrate effective applications of the scientific method. And we aim to show how science research actually gets done. And we have our department right around us. And so the teachers can witness a lot of scientific research getting done around them. So that's very important part of the workshop also. And just to sort of be a little more specific, I want to just highlight the black holes workshop that, again, we taught last summer. There were a number of content presentations. I taught these in general. I started off talking about Schwarzschild solution for black holes. I then talked about stellar fates and black hole formation. And then I talked about observations of black holes, both stellar mass black holes in our own galaxy, and then supermassive black holes, both in our galaxy and then in active galaxies, and then hibernating in other galaxies. And then after covering all that material, I moved on and talked about some selected topics of interest: spinning black holes, the no-hair theorem, black hole evaporation, singularities, and what goes on inside black holes, and so on. So those were the main topics covered. The teachers asked many questions about these topics as we went through them, so there was a lot of valuable back and forth, which enriched the whole experience for the teachers. In addition, of course, to these content presentations, of course, these activities that I've mentioned, again, led by Chris Palma and Glenn Goldsborough, are critical for the success of the workshops. There were activities on modeling black holes in the classroom, investigating stellar density and the compression of a star down to make a black hole with compressing down tinfoil balls. There were coverage of resources and activities to teach stellar evolution. There were also tutorials on finding black holes in binary systems. There was a review of planetarium resources on black holes. There was also connections with the Sloan Digital Sky Survey. Here are the teachers holding their Sloan Digital Sky Survey plates that they learned all about, and they brought these back to their classrooms to teach their students about the Sloan Digital Sky Survey, also Rubin Observatory and other modern surveys. And then, of course, there's also rooftop observing. Here's an image of the teachers, I believe, observing the sun on the Davy Lab roof. And then here is a nice activity that is done where Chris and Glenn put heavy weights on a stretchable cloth to sort of give the teachers a visual understanding of the curvature of space-time close to a black hole. So there's a number of critical activities which help to make the workshop successful. In terms of assessment and follow-up, well, number of points there. Well, after years of iterative improvements, the workshops now receive excellent formative and summative evaluation scores and comments. The attendees especially appreciate, according to their comments, the comprehensive and in-depth coverage that the workshops are able to provide. And the workshops have also been positively reviewed over the years by the Penn State Center for Science in the Schools, an independent center at Penn State, and also the Pennsylvania Space Grant Consortium. And after the workshops are completed, we strive to maintain contact with the teachers via social media groups and email so that we can help them if they need help putting out, preparing lesson plans and so on, and making sure the material gets out to their students. And it's gratifying to see that the workshops have indeed helped the attending teachers confidently teach astronomy concepts and prepare relevant lesson plans. And then, more broadly, in terms of lessons learned for the workshops, well, the workshops clearly are hard work, but they are highly rewarding. And iterative improvement year over year is critical. You won't get everything right the first year, but if you keep improving them, after a couple years, they can get to be very good. I found that year one of a new workshop is especially tough. It's like teaching a new classroom course, but without much of the standard university support framework, because these are often done outside the normal university curriculum. So there's a fair amount of bureaucracy that has to be done, in addition to all the classroom preparation work to make the workshop successful. It is also good to cross-pollinate the workshop material with one of your standard classroom courses. I teach a course on black holes for our undergraduates, and I can use that material to improve the workshops and then take the workshops and use them to improve my classroom teaching and so on. That's also very valuable. And then, well, for long-term success, I believe you may need to plan ultimately to develop content for 2 to 4 workshops. Otherwise, the teachers who have interest tend to saturate and the attendance can drop off. But if you have a variety of workshops, you can keep things vital and interesting for the teachers. And then it is also extremely helpful, as I've mentioned, to team up with education experts and a high school teacher. They give extremely valuable perspective, especially getting the direct inputs from a high school teacher as to, well, this approach will work and this approach will not work. That can help you avoid a lot of pitfalls. And then, of course, it takes an engaged department to sustain a workshop program more generally, at least in my experience. And so, reaching out to your colleagues in the department and your department head and getting them involved in the workshop can be extremely valuable as well. And then just to end, I would like to thank our sources of support, the National Science Foundation, the Penn State Eberly College of Science, specifically our Department of Astronomy and Astrophysics, and also the Penn State Bookstore through Barnes & Noble. Thank you.